Hi, in this video, I will be talking about binomial probability distribution. It makes use of discrete random variables. We will define what a discrete random variable is. Random variable x that can assume a countable number of values are called discrete. For example, I can count the number of heads when a coin is tossed 10 times. In that case, the possible values of my random variable x will be 0, 1, 2, all the way to 10, which is n in this case. Now, we have this question. A couple plan to have 3 children. Let the random variable x be the number of girls on 3 trials. Is the random variable x discrete? In this case, the answer will be yes, because we can be able to count the number of girls. Next, we want to list the possible values of x. In this case, the possible values of x will be either they have no girls, 1 girl, 2 girls, or 3 girls. Now we want to make a simple probability distribution table by listing all possible values of x and the corresponding probabilities of x. To be able to do that, we need to look at the sample space. To be able to obtain the sample space, we can use a probability tree. Please see my video on probabilities to see how to make this sample space. So this sample space lists all of the possibilities. Now, based on this sample space, we can make a simple probability distribution table. When we look at this table, our random variable x is counting how many girls. So we have 0, 1, 2, or 3. Now, the probability that they will have no girl by looking at the sample space will be the case where they have 3 boys. That will be 1 out of 8. The probability that we have 1 girl will be the case where they have 2 boys, a girl, a boy, a girl, and then a boy, a girl, and 2 boys. So in that case, we have 3 out of the 8 possibilities. The case where they would have 2 girls will be the case where they have a boy and then 2 girls, a girl, then a boy, and then a girl, 2 girls, and then a boy. So again, we have 3 options out of the 8 options we have. And lastly, a case where they will have 3 girls will just be 1 that we see right there, which is 1 out of 8. So if we sum the probabilities in that column, it's going to come to 1. So we see that this is an example of a simple probability distribution for this particular scenario. Next, we can answer the question, find the mean, variance, and standard deviation. To be able to do this, we will be using the formulas. Now, to be able to use the formulas, let's look at the formula for the mean. If we look at this column right here, we can take the product of x and corresponding values of p of x. For example, in that first cell, I'm multiplying 0 by 0.13. And then I'll repeat throughout that column. When I add up all I have in that column, it would be my mean. So the formula in this case is x multiplied by p of x, the sum of that, which is 1.5. Next, we use the other formula to find the variance. The formula we need here will be summation x minus mu squared multiplied by p of x. If we go back to that table, we create another column. We call it x minus mu squared. Now, in that cell, I'm taking x minus the mean is the mu is the mean we just obtained, which is 1.51. So for example, in this first cell, I'm taking my x, which is 0, minus 1.51. I'm putting a parenthesis around it and I'm squaring it. So when I repeat that for all of the cells, it gives me all of the values in that column. And then I'm going to be multiplying the values in this column by the corresponding probabilities. For example, in this cell, I have 0.13 times 2.28. And then I'm going to repeat that for the whole column. Now, when I'm done, I'm going to take the sum, and the value that shows up becomes my variance, which in this case, to 2 decimal places, is 0.75. Next, I simply find the standard deviation by taking the square root of the variance. So the square root of 0.75 gives me 0.87. Now, looking at this part of the question, is the example we just looked at a binomial distribution? The answer is yes. Now, the second part of the question is for us to explain why. Now, we look at the properties of our binomial random variable. The first property says that the experiment must consist of n identical trials. In this case, they want to have 3 children. So my n in this case will be 3. Then the second case will be there are only 2 possible outcomes on each trial. So in this case, the possible outcomes every time they have a child will be either a girl or a boy. The third property or characteristic, the probability of S must remain the same from trial to trial. For example, if I call my success in this case girl and failure boy, the probability of having a girl must be 1/2 every time they try. And the probability of having a boy, which is Q in this case, must also be 1/2. Please keep in mind that P plus Q must always be equal to 1. The fourth characteristic, the trials are independent. We know that every time they try to have a child, that it's independent of what happened before. So in this case, the trials are independent. Lastly, the binomial random variable x is the number of s's in n trials, number of successes in n trials. So I can count my x in this case. Our success in this case is having a girl. So they may have no girl, 1 girl, 2 girls, or 3 girls. So since all of these properties are satisfied, that makes it a binomial distribution. Now, this will be the general formula, the probability distribution function for a binomial distribution. In this case, I'm replacing my n by 3. Again, you keep in mind the p in this case is 0.5. My 1 minus p also will be 0.5. And my x will take on values from 0 to 3. So looking at the next question, what is the probability that they would have exactly 2 girls? So we want to use a binomial table to answer this question. Now we're answering these questions based on the fact that we have established that what we have here is a binomial probability distribution. So we have a part of our binomial table as given right here. So from our binomial table, we have our n across the top. In this case, my n is 3. My p, probability of having a girl, is 0.5. And my x, they want to have exactly 2 girls. So my x in this case will be 2. So when I look in that column, I'll find under the column for x, 2. I find across the top my p to be 0.5 and my n is 3. If I look in that intersection in the table, it comes out to be 0.375. Going to the next problem, what is the probability that they will have exactly 1 girl? Here we want to use the binomial formula. I showed you the binomial formula earlier. This time around, anywhere we see x, we put in 1. Anywhere we see n, we put in 3. And anywhere we see p, we put in 0.5. Now, when we put all of that together into the formula, in parentheses right here, this is 3 combination 1. So that will give us a 3. We compute 0.5 raised to the power of 1. It gives us 0.5. Then another 0.5 to the power of 2 gives us 0.25. Now, when we take this product, the probability comes out to be 0.375. Now, I'll be solving the rest of the problems using Excel. The C part says, what is the probability that they will have no boys? In this case, no boys means my X will be 3 girls. They have 3 trials, so no boys. That means that all 3 trials must be girls. So in this case, my X must be 3. My N also is 3 and my P is 0.5. So if you wanted to use Excel, I just need to go to any cell in Excel. I will type binom.dist. In the first position, I have my X. In the second position, I have my N. In the third position, I have my P. And I'm putting in false here because it's not a cumulative probability. I just want it as a single point. So I'll put false. And then I hit enter and it returns the probability of 0.125. The D part of the question says, what is the probability that they will have at least one girl? In this case, I want probability of X greater than or equal to 1. Here, it will include the X values will be 1, 2, 3. If I wanted to use the table or the formula, I could find the probabilities at 1, 2, and 3 and add them up. Or if I was going to use Excel, I can just simply use the complement rule. This will be the same as 1 minus the probability of no girls. So in that case, I will just go to Excel and then put in my X value to be 0 for P of 0, my N value to be 3, my P to be 0.5, and then false because I just want at the point X is equal to 0. Whatever value I obtain, which in this case will be 0.125, I will subtract from 1. So in that case, the probability they will have at least one girl will be 0.875. The next question says, what is the probability that they will have at most 2 girls? At most 2 girls is X less than or equal to 2. In this case, the values for X will be 0, 1, and 2. Again, if you were finding individual values, you'll find those values and add them up. Or you can simply go to any cell in Excel. You put in the value of X to be 2, the value of N to be 3, the value of P to be 0.5, and then true because it's cumulative from 0 to 2. So it returns the value of 0.875. The next question, we're supposed to find the mean, variance, and standard deviation. Now to do this, we simply use the formula for binomial distribution. To compute the mean, it will simply be my N multiplied by P, which in this case is 3 multiplied by 0.5, which gives me 1.5. My variance will be N multiplied by P multiplied by Q, which in this case is 3 multiplied by 0.5 multiplied by 0.5, which will give me 0.75. And lastly, my standard deviation will be the square root of the variance, which in this case is the square root of 0.75. Thank you for watching this video.